Here is our Libre model. Pay attention to this face, and our post, because we're going to alter those values later. Now we're going to go into EZCAM, and we're going to transfer our model. Go to the File tab, Libre model, and we're going to position our coordinate system for machining. Go to our Easy Wizards. Take a quick look at our 3D part with Rapid Cut. And you can notice the size of our post and the depths of our slot. Now we'll go into a Libre again. We'll start by modifying the diameter of our post from 10 millimeters to 25.4. Now we'll modify the slot depth. Pick that slot. Okay, that one's updated. We'll update this one. Now we'll go into EZCAM. We'll take this post and these depths of these faces, and we'll update that by going back to the Libre model transfer. You can see our depth has changed and our post. We'll recalculate our machining. So you can see we have parametric programming in a Libre and associative machining in EZCAM. EZCAM is optimized copy and paste. You can copy geometry, surfaces, and solids from one document to the next, or you can transfer entities from layer to layer. Now I'll move that geometry into plain sight. We only want to move layer 2. And you can see this is one of the many benefits to 2020. EZCAM has created a new startup window. At the top, you will see the products available. By selecting one, you will open a new document. Below that, you have the last 4 folders you were working in. Then you have the graphics, which represent the last file saved or a file favorite. You can make it a favorite by clicking on the pin in the upper right-hand corner. If you right-click on an image, it will open Windows Explorer where the file was saved. EZCAM has a new layer manager found under the Edit menu. This is valuable when working with assemblies or simply documents with a lot of layers. Here you can hide, show, delete, copy, and even rename layers. I'm going to select all and hide them, and I'm going to find my base model. When I click on its description, it reveals its contents. I'm going to copy this layer, and at the very bottom you'll see that it's labeled as such. If I slowly left click and release, you can see you have the ability to rename. EZCAM has enhanced hole detection. If we go under Surfaces Standard, Capped Holes is now available. This works great if you want to keep the tool from plunging into a hole when you're using the 3D machining wizard. EZCAM has a couple other hole features, such as circle center and radius can now be circle center and diameter by simply going over to the right hand side and clicking on the R. It changes to D for diameter, and we'll position a few of our holes. And we'll go to the Easy Wizards Hole Recognition. EZCAM will separate the hole diameters. You can see they're linked together by a rapid move. Use the Curve Wizard by double clicking. Up at the top you'll see D.375. So we'll do a drilled hole. 375. And the only thing remaining is the depth, of course. Do the same for the next set of holes. Diameter of 0.75. EZCAM's constant Z roughing is intelligent to start on the outer boundary and work its way up to a boss. In a pocket, machining starts in the middle and works its way to the outer walls. Pockets with a step over of 50% or greater used to leave material in the middle of a pocket. Now with the new variable step over, the material in the center of a pocket will be removed. For those of you that are already familiar with EZCAM's 4th axis machining, you're going to appreciate the new projection styles we have, such as facet. In 2019, EZCAM would take a tool and wrap it around the edges on an open pocket. This would violate a model such as this. Let's take a look. See, we have a rapid move going through the part. If I turn off the shading, you can see the edge roll right here and the tool violation. Let's take a look in a 3D preview. In version 27, 2020, we've adjusted the behavior so we don't violate the models. The tool no longer wraps around the edges. After you've created your work steps and simulated your machining, it's time to post code. EZCAM has a new post-processor dialog with a few added features. Under CNC file, you'll notice that the last post-processors you've used are listed. If you check Save CNC Name in Part File, EZCAM will associate the last post-processor used with the document. Under Listings, you can take no action. You can open up the EasyDNC Express for RS-232 communications, or you can use our new Notepad, our G-code editor. In Notepad, you can make your changes, and you can save the file as any extension necessary for your machine, such as a .cnc or .txt, and so on. Under the Help menu is where you're going to find the toolbox. Convert metric geometry to inch. Convert inch geometry to metric. That comes in handy when your part file is in a different unit than the document you have open. Pick curves of the current work step. Let me show you how that works. Now notice there are only green circles and lines. That represents geometry. The blue represents a path curve. So I'm going to select step 16 in the list box. I'm going to blank or hide all of my curves that are associated with that work step. Go back to our toolbox and then pick curves of the current work step. Notice our pockets, the curves are hidden and the geometry is visible. Back to Help, Toolbox. Pick surfaces of the current work step, works the same as the curves. Set drill diameter of the current work step. I'm going to go to operation 15. You'll notice that the diameter is set to 12 millimeters. In the toolbox, we'll go set drill diameter of the current work step. Pick a circle representing the drill diameter. 6 millimeter. So in operation 15, our diameter has been updated. Back in. Set first feed of all work steps to 0. When you're cutting a pocket the traditional way, the first pass is going to take up 100% of the diameter of the cutter. So you would want your feed rate much slower. Well, with high-speed machining, we keep a nice even chip load on the tool at all times, so you don't need to have a slower first feed. Cutting data calculator. Here's where you're going to calculate feeds and speeds. You can do so for any one of the work steps. Just select one out of the list box. Insert your values, calculate RPM, calculate feed rate, and write them to the work step. Create geometry from all curves. You don't have to use geometry to build a path. This tool here is very good for editing and making changes in your machining. Activate, deactivate work steps. Activating all work steps will produce G-code for all your operations. Activate only the current work step. On the right hand side in your list box, I have 6 selected. That would be the only work step I get code. UCS, if you have multiple coordinate systems, say one on the top of your part, one on the bottom, anything on the sides, it will activate all work steps for the current UCS. The current UCS is what you see down in the lower left hand corner, and the world is our active tool. You can post all the code for a specific tool or a specific curve. Before and after. So before operation 6, 1 through 5 would get posted, and after would be 7 through 16. Deactivate all auxiliary work steps. An auxiliary work step is simply a way to insert custom code before or after a work step. max feed rate of the current post processor. Setting your maximum feed rate will automatically update your post, and this feed rate is used for the return pass on high-speed machining.